Geometry lesson 3-5. So we've been talking a lot about parallel lines and some of the relationships that are created. We don't have a lot to go over as far as this particular lesson is concerned, but we're going to talk about some special relationships between parallel lines and perpendicular lines and maybe what results somewhat based on the transitive theory. So our first concept here is if we have two lines that are parallel to the same line, then they are going to be parallel to each other. So here's what I have. I've got three lines over here, J, K, and L. And if we were to say that J and K were parallel, so J and K were parallel, and we said that K and L were parallel, you'd be basically saying that since these two were parallel here, J and L would have to be parallel. So hopefully you can see that that's very similar to our transitive property. They have in common here. The K is in common, so the J and the L, if you notice that these two are in common, J and L are going to have to be parallel as well. All right. Another situation that it results in a plane, so that means they are not going to be perpendicular or anything drawn in such a way that it would look like this, because this would not be in a plane. So in a plane, if we had, because we could have lines that were skewed like this and still have a transversal that goes between them. So we want them to be in a plane. In a plane, if you have two lines that are congruent to the exact same line, now congruent to the exact same line that are perpendicular, I'm sorry, not congruent, but perpendicular, means they'd be coming into this line at 90 degrees. This is the transversal, P. So M is perpendicular to P, making 90. N is perpendicular to P, making 90. Then what happens is they're going to be parallel to each other, which would make sense. Just a moment or before, we talked about this being a corresponding angle to this corresponding angle. And if you have two lines that are being cut by a transversal and their corresponding angles are congruent, then they are going to be parallel lines. So we're forcing these to be parallel. And that's what we have in symbols here. If M is perpendicular to P and N is perpendicular to P, then M and N will be parallel to each other. So it's just a few more situations that we have where you can use that information to help yourself determine whether or not you're dealing with parallel lines. And if you have parallel lines, there's a lot more information that we can use about corresponding angles and alternate interiors, alternate exteriors, consecutive interiors, just some different relationships that will help us to either solve for other angles or any relationship that we might have with those sides themselves.